In this session, we are going to look into higher order constructs or hierarchical component models, and we are going to specifically focus on a reflective higher order construct. Now, there are different types of higher order construct. There could be reflective, as discussed in previous videos. It could be reflective formative, or formative reflective. One that is most used is reflective higher order construct. Now, in this video, we are going to talk in detail as to what it is, how it is specified in SmartPLS, and how to analyze reflective higher order constructs and how to report the results. Now, reflective specification. A widely debated HCM configuration is the reflective type. Now, critics argue that this type of HCM does not exist, or actually is meaningless, because the reflective measures should be unidimensional and conceptually interchangeable. However, this conflicts with the view held by others that multiple underlying dimensions are distinct in nature. So, although there is critique on whether there could be higher order reflective constructs, this approach is still available in the literature, whereas papers in good journals have used a similar type 1 reflective higher order constructs. Now, estimation. How do we estimate a reflective higher order constructs? So what we use is the repeated indicators approach. To establish the reflective higher order, we first draw on the repeated indicators approach. What do you mean by repeated indicators approach? Repeated indicators mean that lower order constructs, the items of the lower order constructs are actually repeated in the higher order construct. How do we do it? We'll be talking in greater detail on this. Now, all indicators of the reflectively measured lower order constructs are simultaneously assigned to the reflective measurement model of the higher order construct. Now, this is what we mean by repeated indicators approach. In terms of structural model specification, now if you are developing your structural model, that is, you are specifically looking into the impact of any antecedent construct on the higher order construct, the antecedent constructs directly relate to the higher order component. So you link the higher order component or higher order construct with the other variables rather than linking the lower order constructs. Similarly, higher order constructs are directly related to the criterion variable. Now, first we focus on the measurement model assessment, assessing the quality criteria of the lower order constructs, and then we move into assessment of the quality criteria for higher order constructs. This is normally missing in existing research, whereby if researchers are using higher order constructs, they normally do not report the validity of the higher order constructs. The assessment of lower order components draws on the standard reliability and validity criteria for reflective measurement models, as documented in the extant literature. Assess the model as we normally do in case of LOCs. So you start with the assessment of lower order constructs. All the lower order constructs are assessed for reliability and validity, and they are checked for discriminant validity. The second step is assessment of reliability and validity and discriminant validity of the higher order constructs with the lower order constructs in the study. Now, the approach that is normally used is the disjoint two-stage approach. In the first stage, what we do is we create and estimate the model connecting all the lower order constructs, including exogenous and endogenous construct. So even the lower order constructs of the higher order constructs, they are considered as lower order constructs without specifying the higher order construct. And all these variables are interlinked. This is the first stage. So the first stage, or the model assessment, first focuses on the reflective measurement models of the lower order constructs. So all lower order constructs. In the stage 2, use the latent variable scores of the lower order constructs from stage 1 to create and estimate stage 2 model. So once we have done the first stage, we use the latent variable score from first stage and then model the higher order constructs. For this purpose, locate the scores of LOCs of the higher order construct and add these as new variables to the dataset. So we'll be practically looking into how this estimation is done. So how is it applied? The evaluation of stage 2 actually starts with focusing on reflective measurement model of the higher order component. So once you have done the lower order construct, assessed their reliability and validity, the next step is you have to assess the higher order construct with other lower order constructs in your study and see their composite reliability and average variance extracted if there are other lower order constructs in the study. Now in this case we will use the coefficients that they will now refer to as loadings. Now these results above the critical value 0.5 Cronbach alpha CR and AVE establish reliability and convergent validity. And again we will use HTMT for discriminant validity. And finally for structural model we can use the structural model evaluation, that is path coefficient PLS predict and Q square. If you want to know more detail about how to specify, estimate and validate higher order constructs, this is a very good paper. So please do read this paper. Now moving on, practically how shall we do it? Let's say this is the model that we want to estimate. Here CSR is our higher order construct and these are our subdimensions or lower order constructs for CSR. Now what do we mean by reflective or repeated indicators approach? Now each of these dimensions have got their own indicators. But what about this? What about CSR? CSR is a higher order construct made up of all these 4 dimensions. So in repeated indicators approach, all the indicators of these 4 dimensions will be loaded separately into CSR, as we see like this. So all the indicators of ECC, LC, EC, DC are loaded onto CSR. How do we do this? Just simply drag these items here, just as you did for lower order constructs, just drag them and put it in here. So they'll be loaded onto CSR. So this is repeated indicators approach. And if you see, the arrow is pointing towards the dimension from CSR. So arrows are pointing towards the dimension from CSR. And if you look at the dimensions of CSR like this economic dimension, the arrow is pointing towards the indicators. So this is reflective and then reflective. So that's why it's called reflective. In this case, we are interested in assessing the impact of CSR on team identity as mediator and organizational performance as criterion variable. So how do we test this model? In order to test this model, the first step is we have to assess the reliability and validity of all these lower order constructs. So 4, 5, 6. So the first step is assessment of reliability and validity for the lower order constructs. So how do we do this? So this is how we do it. We have now removed this higher order construct CSR here. See this model? Now CSR is removed and all these lower order constructs are interlinked with each other. So the first step is, when assessing reflective model, is assessment of reliability and validity for the lower order constructs. So we remove CSR and we link each of the lower order construct with the other variables in the study. This is the first stage. Now how do we assess? Simple. Go to calculate PLS algorithm, path and start calculation. Now construct reliability. This is your discriminant validity for null and Larker criterion. Cross loadings, HTMT looks good, but the problem lies here with team identity and DC. Let's see the loadings. If we've got very problematic loadings, we can remove. So in order to evaluate whether this can be improved, we go to outer loadings. And if you look here, well, most of them are over or close to 0.6. This one is fine as well. This one is fine as well. So let's say If you want to improve, you could delete this one, team identity, and this may improve it to the level that it is over 0.50. But if we look into greater detail, and we might find that we might not be able to improve it to an extent that it rises over 0.50. So for the sake of understanding, for now, let's keep it this way. However, since all the composite reliabilities are greater than 0.70, we can say that there is no problem of convergent validity. Now moving on, how do we report these results? So I've got a template here of the chapter data analysis and results. So we first write the introduction, briefly describe as to what analysis technique is we are going to use, followed by the hypothesis in this study. Then we write about the measurement model. Okay, the quality of the constructs in the study is assessed based on the evaluation of the measurement model. The assessment of quality criteria starts with the evaluation of factor loadings, which is followed by establishing construct reliability and validity. So the first thing that we need to report is factor loading. How do we report factor loadings? Okay, it has to be, it is normally between -1 to +1. And in this case, we are not removing any of the items because the loading is greater than 0.50. So how do we report it? So we go to outer loadings and we copy it into Excel format. We bring it here. Let's say we open our Excel file here and we paste it here. So this is how you can report loadings. Let's say we want to go up to 3 decimal points. So we select the numbers, right click, format cells, number, and let's say 3 decimal points, press OK. And now you can copy this from here and put it in your document here. Let's format it a bit. Select, right click, autofit to window. Okay. Let's format the table. So this is how you can report your factor loadings. The next step is we assess the multicollinearity. So multicollinearity is not an issue if the VIF value is below 5. So where is VIF? If we go here, we see collinearity statistics, VIF, and none of them are greater than 5. A few over 3, but that's not a problem. Copy it into Excel format, into new sheet. You cannot copy it directly into MS Word because that will be copied in text format. So you just need to do it in Excel and then bring it from there. So autofit to window. Let's format it. Centralize. So this is how you report your VIF values. Next up, we have to report our reliability analysis. Now this is a brief description of what reliability is and the criteria for reliability. And in this case, let's first report it and then we'll change the values in the text. So where is reliability? If you go to construct reliability and validity, we see that there are different measures here. We will report Cron-Batch alpha and composite reliability. So we'll copy it into Excel format. And in this case, this is greater than 0.70, all greater than 0.70. So the reliability is not an issue for all the constructs in this study. We do not need to report row, so let's delete it. We are not reporting AVE because this is just the reliability assessment. And let's copy this. We can change up to 3 decimal points, right click, format cells, number, 3, OK, and then copy and we'll paste it here. Now arrange it, select, right click, autofit to window. Just centralize the other columns, select the whole table, bottom border, top border, and bottom border for the first row as well. So all lower order constructs are reliable, and we need to change the values. So cron batch alpha ranged from 0.728 to 0.896, that's the higher value, and composite reliability 0.816, that's the lowest value, and the highest value is 0.923, and both these indicators are greater than 0.70, so we say that our constructs are reliable. The next step is convergent validity for the lower order constructs. So briefly describe what convergent validity is. So it is established when the AVE value is greater than 0. However, in this case, there are few items that have got convergent validity or AVE value slightly lower than 0.50. However, since our composite reliability is greater than 0.70, we can say that our constructs are valid. So how do we do this? Just copy it into Excel format. Now we have already reported the reliability, so we do not need these, and we just need this table here. So let's copy, and you can paste it here. Right click, out of it to window, bottom border, top border, and bottom border for the first row, centralize. So this is how you can report your average variance extracted. Now let's change the text slightly, show that all the constructs except for DC and TI have slightly lower AVE. However, the CR values for all the constructs was greater than 0.70. Hence, convergent validity is not an issue. So table 4 actually shows the results for AV. Now moving on, discriminant validity. So discriminant validity is the degree to which measures of different concepts are actually distinct. There are three different methods through which we establish discriminant validity. The first one is Forner and Larker criterion. So how do we report Forner and Larker criterion? So where is it? Here it is. Discriminant validity, the first one is Forner and Larker. The top value, which is the square root of AVE, must be greater than all the values underneath, which are the correlation of this construct with all the other construct. So what is this? 0.687. This is square root of AVE of DC. And this must be greater than all the correlations of DC with all the other constructs. Similarly for all the other constructs as well. So this value is higher the other constructs or the correlation of other constructs? Yes. This is high? Yes. This is high? Yes, 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 yes. Obviously there are no underlying values because all other correlations have already been checked. So this would have been repetition if we add any values here. So how do we report it? Copy it into Excel format. Go to Excel, paste it here, and then you can copy it from here or change the format as well. Right click, format cells, number, 3 decimal points, press OK, and we copy it from here and we paste it here. Right click, out of it to window, and we can obviously give it the format that we require. Now in order to make it more clear, let's change the square root of AVE to bold and italic, and this value must be higher than all the values underneath, which are the correlation of that construct with all the other constructs. The other method is cross-loadings. So where is cross-loading? Cross-loading. So each item must load well onto its own factor than other factors in the study. So DC1, the parent construct is DC, so it's loading better than all the other constructs. Similarly for, let's say, EC1, it's loading better than all the other constructs. Let's say ECC1, it's loading better 0.828 than the other constructs. So as we see, there is no problem. The difference in the loading is greater than 0.10. So what we do is we copy into Excel format, paste it here, and then we can obviously highlight the items within a construct. Let's say like this, similarly like this, similarly like this, like this, like this, and then the TI. So what we can do is just copy them from here and let's paste it into our results like this. Right click, autofit to window, and again rearrange it. Now moving on, heterotrait monotrait ratio, the threshold is 0.85 or 0.90. Now how do we report it? The next step, heterotrait, just copy it into Excel format, paste it here and copy it and paste it into your results document. Right click, autofit to window, and let's arrange it. Bottom, top, and the bottom border for the first row. Now this is how we report the reliability and validity for the lower order constructs. So if we've got a higher order construct and we've got the lower order constructs in our model, this is how we first report the lower order constructs. So all the lower order constructs are reported in this manner. So once this is done, the next step is establishing the reliability and validity for the higher order constructs. If your model is reflective. Now how do we do this? How do we validate our higher order constructs? So this was stage 1. Now the next stage is, before we go on to next stage, we need the latent variable scores. And this is the latent variable score. Under final results, we see latent variable. So this is latent variable score. And you will find 200 cases in there, similar to your records or the number of records you have in your data set. 200. So what we need to do is, we need to copy it into Excel format. So once that is done, open your original data set. Here is the data set. And what you need to do is, right at the end of this data set, you need to paste the values. Well, in this case, I've already done this. So let's remove this for now. And what you need to do is, you need to paste that data that you have copied from here into your original data set here. Remove the case ID. Now the next step is, we save as, and let's say we name it data file as PSS, latent variable score, LVS. It has to be CSV rather, and we save it. Close this file. And the next step is, you need to import that file. Right click, import data file. Locate your file. Here it is, LVS score. Press open. Okay. And you see, here is your latent variable score for the lower order constructs. And this is how you import the file. Now the next step is that we need to test the higher order constructs. Now this was your lower order construct. All lower order constructs tested for reliability and validity. But what we are actually interested in, we are actually interested in testing CSR, its impact on OP and TI. Now before we move on, we have to validate the higher order construct as well. So in order to do this, what we need to do is, now the indicators for CSR are ECC, EC and DC. But what we see here in repeated indicators approach is that these are the indicators for CSR. But actually these are not the indicators for CSR. These are the indicators for the lower order constructs. The indicators for CSR is ECC, LC, EC and DC. These lower order constructs should be the indicators for CSR instead of these items. So what we need to do is, we need to remove this and remove these lower order constructs as well. Now this is your stage 2. What you need to do is, you need to bring in DC, EC, ECC and LC, which are the lower order constructs for CSR. Now they will serve as the indicators for CSR. We bring it onto the model. Now this is your CSR. If you see this model, CSR has 4 indicators: ECC, LC, EC and DC. But in order to get to this stage, we have to pass the first stage and then get to the second stage. And during the second stage, once we've got the LVS scores, what we do is we add them as indicators for our higher order construct. Now since it's a reflective, so the arrows will be pointing towards the indicators or the lower order constructs that we have now got the scores for. And then we connect it to TI and we connect it to OP. Now we will validate this higher order construct with these lower order constructs. So in order to do this, again go to calculate, PLS algorithm and press start. Now if you go to construct reliability and validity and you see that, okay, CSR slightly lower Cronbach alpha because of the number of items, the AV value is good enough. So we do not need this, we've already done this, we just need this top row here. So copy it to Excel format, put it here. Now we do not need the next ones, so we'll delete this. We are not reporting row, so we'll delete this. And let's copy this. Copy and we paste it here. Right click, AutoFit, window. Lower border, top border. So this is the reliability and validity for the higher order construct, that is CSR. Now the next step is discriminant validity according to Forner and Locker criterion of the higher order construct with the other dimensions. So how do we get this? Simply go back to discriminant validity and here it is. Just copy it into Excel format, paste it here and let's copy it back onto Microsoft Word. Here it is. And similarly, we'll do this for HTMT as well. Let's do it for HTMT as well. You do not need to report cross-loading, just 2 methods are enough. Even HTMT is enough. So Excel format and let's paste it here. Let's again copy it and paste it back. Right click, AutoFit to window, bottom border, top border. And then arrange it. So this is how you report or validate your higher order constructs. Now see, the reliability and validity both are good. The Foreign and Larker criterion is also good enough, or rather it's very good. HTMT all less than 0.85 as shown. So this is how you can report or validate higher order constructs when you've got a type 1 model, reflective. Now the next step is assessment of your structural model. How do you assess the relationship between variables? So once you have done the reliability and validity for the lower order constructs and you have done the validity for the higher order construct, the next step is testing the relationship. Now in this case, our H1 is this: there is a significant impact of CSR on organizational performance. Now how do we do this? Simply go to calculate, bootstrap. Normally it's 5,000 recommended, but now since we are short of time, so just run the model with basic bootstrapping, or rather let's do complete and then start. Now here are our results, our hypothesis results, the direct relationships. So you can copy it into Excel format, paste it here. We do not need the sample mean, and let's copy this back, Control C. I'm just going to do one, and then you can obviously do similarly for the rest of them. Right click, auto fit to window, and let's arrange it a bit. Bottom border. So H1 evaluates whether CSR has a significant impact on the organizational performance. This is your H1. So let's write H1 here. The results reveal that CSR has a significant impact because the p-value is less than 0.00. If we add the 3 decimal points as was in the SmartPLS output, so the beta value is 0.386. The t-value is greater than 1.96, 3.882, and the p-value is less than 0.001, sorry. So hence your H1 was actually supported. Similarly, you can do this for the rest of your hypothesis. In this case, I'm not going to do this. Let's go directly to mediation. So these are your hypothesis results for H1, H2, and H3. Now, how do we report the mediation results? In this case, our mediation is that team identity mediates the relationship between CSR and organizational performance. So let's go back and look at here. So the first thing that you need to do is you need to look into specific indirect effects. And in this case, there is no mediation because the p-value is greater than 0.05. So how do you do this? Mediation analysis was performed to assess the mediating role of TI. The results, see table 12, revealed a partial mediating role of TI. So the beta value is, so let's say if we take the significance level to 0.10, then it can be a significant mediating role, 0.078. The t-value is 1.736. And the p-value is 0.083. Now the total effect. So what's the total effect? Here it is, the total effect. Without the presence of the mediator, the impact of CSR and OP was significant, 0.463. And the t-value was 5.532. And the p-value was less than 0.001. Now with the inclusion of the mediator, the direct effect. So what's the direct effect? When the mediator is included in the model, then we've got the direct effect. Here it is, 0.386, 3.882. But the direct effect is still significant. With the presence of the mediator, there is still effect of CSR on OP. So some of the effect is actually passing through team identity, and the effect is also passing directly from CSR to OP. So what we can say is that TI, it partially mediates the relationship between CSR and OP. So this is how you report your mediation results. Further, this is how you can report it in the form of a table. I'm not going to repeat it. So the total effect goes here, the direct effect goes here, and the indirect effect, the coefficient, the standard deviation, the t value and the p values will go here. You can report your structural model, this one here, this model here. Just copy it, file, export to clipboard, and you can paste it here. So if your model is reflective, this is the approach you can use to run the model and report the results. Just make sure that after you do your lower order constructs, your first stage, and you have assessed the reliability and validity, you take the latent variable scores, export it into Excel format, paste it into your original data set, import that original data set, and then use that data set for your analysis. Now the higher order construct will be indicated by the latent variable scores that you have generated for the lower order constructs. Plus, since it's the disjoint two-stage approach, the lower order constructs will remain as is. See, these are indicated by the items, not the latent variable scores. Only the higher order construct is indicated by the latent variable scores. And this is how you can report it. I hope the video would have helped you understand the concept of reflective indicators and how to report the results. Thank you very much.